We're going to continue our review over quadratic functions. We looked at factoring quadratics, we looked at factoring completely, and today we're going to apply those concepts to solving by factoring. So just some reminders, the standard form of a quadratic equation is y equals ax squared plus bx plus c. Before we do any factoring, we need to make sure that our equation is in this form. Some new terms, the roots or zeros of a quadratic expression, those are the values for x that make the value of the quadratic expression equal to 0. Essentially, what is x when y is 0? Which is another name for an x-intercept, as the x-intercept is the value of x when y is equal to 0. So the terms roots, zeros, x-intercepts, those are all interchangeable. So to begin, when solving for the roots, zeros of a quadratic equation, we must set y equal to 0. The reason why is because of something called the zero product property, which states when the product of two or more numbers is 0, one of those numbers must be 0. So if I have a product of two or more numbers, I can set both of them equal to 0 to help me solve the equation. This is going to be especially helpful for our quadratic equations since we have learned how to write them as factors through the process of factoring. So let's look at one. Solving for the zeros for the quadratic function y equals x squared minus 2x minus 15. Step 1. Set y equal to 0. Done. Step 2. We're going to factor the quadratic expression x squared minus 2x minus 15 by using a generic rectangle and a diamond. Remembering that the ax squared term and the c term go in opposite corners, I multiply those two together to get the product for my diamond. I look inside my expression to find the bx term. That's the sum of my x values. I'm going to look for my factors of negative 15x squared that add to give me negative 2x. Between all of my pairs here, negative 5x plus 3x is going to add to give me negative 2x, but multiply to give me negative 15x squared. Those are the two factors that complete my generic rectangle, and I then factor each partial area. Rewriting x squared minus 2x minus 15 as 0 is equal to x plus 3 times x minus 5. Step 3 is to use the zero product property and set each factor equal to 0. So I'm going to set x plus 3 equal to 0, and I'm going to set x minus 5 equal to 0. And then I just solve each equation for x. Subtracting 3, using my inverse operations, and adding 5, and I get x equals negative 3 and x equals 5. So what information does the zeros roots give us? These roots, essentially they tell us our x-intercepts. When I plug in 0 for y on a graph, or in that equation, I get negative 3, and I also can get 5. Which tells me that this equation has two x-intercepts, one at negative 3 and one at 5. This information will become useful when we get into graphing these equations. Let's try another one by solving by factoring. Solve for the zeros for the quadratic function y equals 2x squared plus 8x plus 6. Step 1, set y equal to 0. Step 2, factoring this expression. Now, 2x squared plus 8x plus 6. If you remember back to factoring completely, we always need to ask ourselves, is there something that we can divide out before we begin the factoring process? And in this case, yes, we can divide out a 2 from each of my terms. So 2x squared plus 8x plus 6 is the same as 2 times the quantity x squared plus 4x plus 3. I now have a smaller values in my trinomial that I can factor to make this equation a little bit more efficient. So I'm going to go through the process of factoring x squared plus 4x plus 3 by multiplying my ax squared term and my c term, writing the b term as my sum for my diamond, and looking at my factors of 3x squared. There's only one pair of factors that give you 3x squared that add to 4x, and that's x and 3x. I then find the factors for each of my partial areas, and I can rewrite this expression as in my equation as 0 is equal to 2 times x plus 1 times x plus 3. Now to begin to solve this, I can divide both sides by 2. because I want to set each of my factors, x plus 1 and x plus 3, equal to 0, so that I can use the zero product property. Remembering that any number, when you have two or more products that multiply to give you 0, then one of those products has to equal 0. So I'm going to set both products equal to 0, x plus 1 and x plus 3. And when I solve, I get x equals -1 and x equals -3. Let's try one more, solving by factoring. Solve for the zeros for the quadratic function y equals x squared minus 3x minus 7. There's nothing that I can factor out to begin with, so I know that it's not going to be a factoring completely problem. I'm going to plug 0 in for y, and I'm going to move with the process of factoring by using a generic rectangle. Ax squared in one corner, c in the other, multiplying those two together to get my product, looking at my equation at the bx term to find my sum. Now the factors of -7x squared are -7x and x, and +7x and -x. But what do you notice? Neither of these pairs of factors are going to add to give me -3x, so we're stuck. We're not able to factor this equation, x squared minus 3x minus 7. Does that mean it doesn't have any roots? Does that mean it's not possible? Well, the truth is this problem does have roots, and there are other methods that we're going to learn to use this. So we're going to have to find another method in order to solve this quadratic equation. Unfortunately, we're not going to be able to solve it by factoring, so we're going to stop here. So that's a review over how to solve by factoring.